Hello everybody. Today I can find z-score using z equals x minus mu over sigma. So let's talk about what z-score is and when we want to find z-score. We use z-score to compare scores from different distributions, from different events. So let's say that yesterday I was tutoring two different students in two different schools, in two different courses. Let's say I was tutoring someone in Algebra 1, and then after that I tutored someone in Pre-Calc, and they both had tests today. And I want to know who did better on their exam. Well, Pre-Calc's a harder test. So a higher score doesn't always mean that the student did better. So maybe the student in Algebra 1 ended up getting a 92, and the student in Pre-Calc ended up getting a 90. So the question is, who did better? Is 92 in Algebra 1 better than a 90 in Pre-Calc, a harder course? So to answer that, we find the z-score. The z-score is who did better in comparison to everyone else. And what we use in order to visualize this is the standard deviation curve that we did the other day. Basically, whichever score falls further to the right is better. So if the algebra 1 score had a mean of 90, let's say, and a standard deviation of 1 or 2, it would look something like this. And maybe the pre-calc had a mean of 80, because it's a harder test, and a standard deviation of 3, let's say 4. You know, that 90 in pre-calc would fall here. The 92 in Algebra 1 would fall here. So the blue is better. The 90 would be better in that case. Because compared to everybody else, that 90 was better on that exam. So to measure this, we call it the z-score. And the z-score measures how many standard deviations you are above or below the mean. And we use z-score to compare scores from different events, from different distributions. So the formula is listed right here. Z equals x minus mu over sigma, where z is the z-score, x is the data point, the test score, or whatever the problem is talking about. Mu, we talked about, is the mean, and sigma, we talked about, is the standard deviation. So let's start by doing some calculations. It wants me to find the z-score of the following test scores. Well, z equals x minus mu over sigma. Z equals, so x is the test score. The test score here is 78 minus mu. Mu is the mean. The mean is 78 over sigma is the standard deviation, which is 4. 78 minus 78 is 0 over 4, which is 0. So basically, that would fall right here, right in the middle. 82. Z equals x minus mu over sigma. X is the score. Mu is the mean. Sigma is the standard deviation. (82 minus 78 is 4. 4 over 4 is 1. Why don't you pause, try 3 and 4 on your own, and then unpause. Okay, now that you tried number 3 and 4 on your own, z equals x minus mu over sigma. Z equals, the score is 73, the mean is 78, sigma, the standard deviation is 4. That's negative 5 over 4. You can leave it as negative 5 over 4, but I feel like with standard deviations, I'd rather see them as decimals, negative 1.25. So what that means is that that score is negative 1 1/4. It would fall here, below the mean. If it's negative, it's below the mean. If it's positive, it's above the mean. Z equals x minus mu over sigma. Z equals 87 minus the standard, the mean is 78 over the standard deviation is 4. That's 9 over 4. That's 2.25. So to find the z-score, it's just substituting into a pretty simple formula. Z equals x minus mu over sigma. This formula is not given to you, so it is something you have to have memorized. This is just more practice. And now this is kind of the application of it. In most colleges, course grades are assigned by how students perform in comparison to the rest of their classmates, not their actual grades. Now, that's absolutely correct. I've got a little story for you. Back in college, SUNY Buffalo in the early 2000s, I was taking a Calc 2 class, and it was a really hard class, and the teacher wasn't a very good teacher. He didn't really care that he wasn't a really good teacher. So, like, the grades were just, like, ridiculous. The grades were out of 100, but I mean, like, they were not very good. So I feel like I got like a 50-something or a 60-something on a test, and it was an A. Because even though it was a 50 or a 60 out of 100, I got one of the highest grades in the class. So compared to my classmates, that was, in the top whatever percent. So here's literally how a lot of college grades work. And they literally use the normal distribution curve. You might find this eye-opening. C, B, A, D, F. That's literally how the grades are done. And of course, maybe, for example, if you're in the B range, if you were like over here, that might be a B plus, and that might be a B minus. But that's literally how a lot of colleges, especially these big lectures, I had these classes that had like 200 kids in them. They literally take the grades, they calculate the mean, they calculate the standard deviation, they throw them on the normal distribution curve, they draw in the lines. If you're within one standard deviation of the mean, it's a C. If you are 1 to 2 standard deviations above, it's a B. More than that's an A. And then the same thing below. So basically, you have about 2.5% of the class getting an A. You have about 13% getting a B. You have about 68% getting a C, about 13% getting a D, and about 2.5% getting an F. That's literally how things are done in most colleges. At least they were 20 years ago when I was there. So, that being said, let's get back to this question. The first test had a mean of 70 and a standard deviation of 5. So, test 1. A mean of 70, a standard deviation of 5. And then the second test, test 2, had a mean of 62 and a standard deviation of 4. Jen scored a 60 on the first test and a 57 on the second test. On which test did she do better? Now listen, some of you might be saying, well, she did better in the first test. She got a 60. That's higher than a 57. It doesn't matter what the actual score is. If you're comparing different events, you need to know how she scored in comparison to everybody else. You need to know where she fell higher on the normal distribution curve. So in order to do that, in order to compare separate events, we find the z-score. So z equals x minus mu over sigma. Z equals x minus mu over sigma. I want you to do the calculation. We just did this on the previous page, so please pause, do the calculations of the z-score, and then unpause. Okay, so for test 1, she got a 60 minus the mean over the standard deviation is negative 10 over 5, is a negative 2. For the test 2, she got 57 minus 62 over 4. She got negative 5 over 4. She got negative 1.25. Which one is better? Well, we have negative 2 and negative 1.25. It might help to look here. This was test 1. The other one, I already forgot it, was negative 1.25. This one's test 2. Which one did she do better on? Which one did she go higher up on the normal distribution curve? Test 2 is better. Test 2 is closer to the average than test 1. Test 2 is further to the right. Test 2 is a higher z-score, so test 2. So even though she got a lower numerical grade on test 2, she probably got a higher actual grade. She probably got probably got like a C minus on this one, and she probably got like a D minus on that one. So it's not just about the number grade, it's about how you're doing in comparison to everybody else, and that's what z-score measures. I want you to take a look at number 10 on your own. So please pause, try number 10, and then unpause. Okay, now that you tried number 10 on your own, I will go over it. Ricky and Marissa are very competitive with each other. Ricky took a physics test where the mean was 82, the standard deviation, and he scored an 85. Marissa took a chemistry test where the mean was 78, the standard deviation was 6, and she scored an 83. Who scored better on their exam? Well, again, you can't go by the actual numerical score because they're totally separate tests and totally separate classes. I need to find the z-score for each. So for Ricky, z equals x minus mu over sigma. Ricky had a score of 85. He had a mean, his class had a mean of 82 and a standard deviation of 4. And Marissa, we're going to calculate her z-score as well. She had a score of 83, mean 78, standard deviation 6. So Ricky's z-score was 85 minus 82 over 4. That's 3 over 4, 0.75. Marissa was 83 minus 78 over 6. Z equals 5 over 6. 5 over 6 is, I think it's like 0.83 repeated. I'm just going to double check that. I don't want to be wrong on video, and then everyone will be like, Mr. Stancy, you don't even know what 5 over 6 is. Come on. I got it right. So, which one is better? 0.83 or 0.75? Well, they're really close, but the 0.83 is better, so Marissa did better. That's obviously very close. 0.75 and 0.83. Let's look at the curve. Let me just kind of erase some of this here. .75 would be like right here. 0.83 would be like right here. I mean, they both probably got a C plus based on that. But, technically, Marissa did better. All right, there's just two more. This is a trickier question conceptually, so we're going to go over it. Number 12 is going to be pretty much the same thing, so this will be the last example that we go over, and number 12 you'll be able to do for homework. So Ricky and Marissa have their next exam coming up. Ricky scored a 92 on his exam, where his classmates' grades had a mean of 84 and a standard deviation of 8. In Marissa's class, the mean was 80 and the standard deviation was 4. What score would Marissa have to get to say she did better than Ricky? Well, to do better than Ricky, she needs to have a better z-score. So the first thing I have to find is I have to find Ricky's z-score. So to find Ricky's z-score, I do my formula. And again, when I'm comparing, in order to say she did better, I need to know their z-scores. It's all about the z-score. Ricky got a 92. His classmates got an 84 and a standard deviation of 8. So Ricky's z-score is 1. 8 over 8. Ricky's z-score is 1. So what score would Marissa have to get to say she did better? So Marissa needs a z-score that's higher than 1. So let's see what score she would need to get to tie him. If she had a z to tie him, she would have to have a z-score of 1. So again, my formula, z equals x minus mu over sigma. So her z-score would be 1. The score itself is what we're trying to find. The mean for her class was 80. The standard deviation for her class was 4. So now to solve this for x, I would do a little bit of algebra, multiply both sides by 4. 4 equals x minus 80 plus 80 plus 80, x equals 84. So a score of 84 would tie him, would give her the same z-score. So what would she have to get in order to do better than him? Assuming that there are no half points, she would need an 85. So this question was worded a little bit differently. You had to first find Ricky's z-score. In order to compare Marissa and Ricky, I need to know their z-scores. I started by finding Ricky's z-score. Ricky had a z-score of 1. So I found what Marissa would need to get in order to tie him to also have a z-score of 1 by replacing the z with 1 and solving for x. And if she wants to do better, she's got to get at least 1 point better, at least an 85. So 12 is pretty much the same thing. And again, z-score compares separate events. There's a formula, z equals x minus mu over sigma. Whichever score has a higher z-score is considered a better score. In the scope of things, this is not asked much on the algebra region, on the algebra 2 regions, if at all. So in the grand scheme of things, it's not the most important lesson in the world as far as the regions goes, but I find it kind of interesting. I feel like a lot of students also find this interesting here, and that's basically how it works. So your classwork/homework is to finish this, and I hope everybody has a wonderful day.